to Mr. Baker's House of Knowledge.
All right, today we're going to be talking about isosceles triangles. I love isosceles triangles. If I don't die. I love isosceles triangles because isosceles triangles are triangles that have two sides that are the same length. And so if I look at a picture of two triangles like I have here in the top center here, if I look at two triangles and I know that two sides are the same in the triangle right here, so here we have AC and BC, and they're marked congruent. So if they're the same, that means I have an isosceles triangle. By the isosceles triangle theorem, I can say that the two angles that are opposite these two sides are congruent. How many people have ever heard of an isosceles triangle before? Hopefully most of you. Good. And so an isosceles triangle is a special triangle. So the congruent sides are called legs. The reason they're called legs is because the triangle could run away on its two. I don't know why. That's not true. I don't know why they're called legs, but they are. The things that are the same are called the legs. Maybe you could think of it as, hey, both of my legs are the same length, hopefully. So that's why the sides of the triangle would be the same. And then the side that's not the legs is the base. So we got the base and the legs. The angle that's opposite the base is called the vertex angle. The vertex angle will be included in between the two legs. And the two angles that are not the vertex angle are called the base angles. All right, so in this picture, if you know that two sides are the same, they're legs, and the base angles will be congruent as well by the isosceles triangle theorem. And here's what's cool about that. We can use the converse of the isosceles triangle theorem, and if we start out with angles congruent, the two base angles, if they're congruent, then we know that the legs will be congruent as well. And the legs are going to be the pieces of the triangle that both touch the base angles. So what I would do is I'd make a note card, isosceles triangle theorem here. If given this, you know that. If given this by the converse, you know that. So the new information is what you can say. So you'll have something in a proof where you'll have to say angle A is congruent to angle B, and the reason will be isosceles triangle theorem. Or you'll have to say side AC is congruent to side BC, and the reason will be the converse of the isosceles triangle theorem. So make a note card on it. It's on your quiz tomorrow. Know it by tomorrow. The converse is when you start out knowing that the angles are congruent, and then you can say that the sides are congruent. So in converse, the given information is the angles. In just the regular theorem, the given information is the sides. So know that distinction.
So on the quiz, would you have to write converse of the...
You'll have to write converse of isosceles triangle theorem or isosceles triangle theorem. Those are reasons. All right, so let's look at some application here. So for this particular picture right here, is AB congruent to CB? And if so, explain. So what is AB? AB is this side right here. And I want to know if the blue side is congruent to the yellow side. Well, notice that the blue side and the yellow side make up legs of an isosceles triangle whose base is AC. So since the angles are congruent, how do we know the sides are congruent? Converse of the isosceles triangle theorem. So yes, and the reason is converse of isosceles, and I don't ever really even spell out isosceles. I just abbreviate it. Isosceles triangle theorem. No. Now, the second question is angle A congruent to angle DEA? So, what does that mean? Well, angle A is right here. And I want to know if it's congruent to that angle right there. Is the yellow angle congruent to the green angle? Well, you know that AD and DE are congruent, so that makes it an isosceles triangle. So you can use the isosceles triangle theorem to say that those two are congruent. So yes, and the reason is the isosceles triangle theorem. Now, this might become useful in a proof because you might have a proof in which you know some information and you have to use that information to get to other information. So if we look at this little itty bitty triangle right here, can we say anything about WVS and WSV? Why? The isosceles triangle theorem. So angle WVS is congruent to angle S by the isosceles triangle theorem. Why is it congruent by isosceles triangle theorem and not converse?
Because it's converse, you get the angles.
Right, because I started with sides and got angles. But now I want to say, is this side right here, TR, congruent to this side right here, TS?
Yes, converse.
Right. So TR is congruent to TS, and that's reason is the converse of the isosceles triangle theorem. Notice that we had to apply the isosceles triangle theorem first to get these two angles congruent, so then I knew that this angle was congruent to that angle to be able to use the converse to get the sides congruent. So without doing this step, we wouldn't have been able to do this step. So sometimes information chains together like that. So we've talked about proofs and we've talked about does order matter. This is a situation in which order would matter. You have to do the first thing first to be able to do the second thing. All right. More isosceles triangle theorems. We're going to get a bunch of them. So this one doesn't have a name. You're basically going to have to write it out. If AC equal BC and ACD is congruent to BCD. In other words, if this line right here is in an isosceles triangle and it bisects the vertex angle. So in an isosceles triangle, if a line bisects the vertex, then it is the perpendicular bisector of the base. So what does it mean to be a perpendicular bisector? And it does two things. It creates right angles and what does bisector do? Cut stuff in half. So if I know that I have an isosceles triangle and I know I have a line that's an angle bisector of the vertex angle, then I know it's going to cut the base in half and it's going to be perpendicular to the base. It's the perpendicular bisector of the base. There's no way around it. That's a note card. What does that mean? Well, here, I'm going to use some algebra to create an equation. In this particular situation, I know that this angle is 54, and I know that this angle over here is x, and I want to solve for x. It would be really good if I know that x is in the top triangle too. It would be really good if I had a number for the third angle, and then I could use x plus 54 plus whatever that third one is to be 180. Because I know the sum of all the angles in a triangle is 180. But wait, here's the exciting part. Isn't this angle congruent to that angle? And isn't this side congruent to that side? This means we're an isosceles triangle. This means we've bisected the vertex angle. What happens when you bisect the vertex angle? It cuts it in half, and it also makes those perpendicular. So now I have 54 plus 90 plus x is equal to 180. Because the sum of the interior angles of a triangle equals 180. I knew this was x because it was congruent with that one. And I knew that was 90 because this was the perpendicular bisector. And I knew this one was 54 because it told me, hey, I'm 54. So now I can combine like terms. When I combine like terms, that's 144 plus x equals 180. And then I'll subtract 144 from both sides, and I think that leaves me with 36. Everybody okay with that? All right. Suppose that the measure of angle A is 27. What is the value of x? So now I know that the measure of angle A is 27 and not 54. Can you guys find the value of x? How would we set it up?
90 plus 27 is
90. Where'd the 90 come from?
Because it's a
The
bisector,
bisector
so it's
makes
also
it perpendicular,
perpendicular,
so it's
so it
90.
makes 90.
So to sum up the dual comments on that is, it's an angle bisector of an isosceles triangle that makes this a perpendicular bisector that makes that 90. So that would be 117 plus x is equal to 180. So what would x equal? 63. But wait, that's not all. There's more. There is a corollary to the theorem that we just talked about. If a triangle is an equilateral triangle, then the triangle is equiangular. That means if all the sides have the same length, then all the angles will have the same length as well. And if the triangle is equiangular, then it's equilateral. If all the angles are the same, then all the sides are the same. So an equilateral triangle is also all of the things that apply to isosceles triangles can apply to equilateral triangles too, except you can use any side as the base. So it even has more things applicable. Yes, sir?
What would you write this on the quiz as?
I would just say if a triangle is equilateral, then it is equiangular, and if a triangle is equiangular, then it is equilateral. So what does that mean? Well, are these two things congruent?
No.
No. But we've got all kinds of little things that we could do here. For example, if I tell you that that's true, what can you tell me about angle A, angle B, and angle C?
They're all congruent.
Yep. Angle A is congruent to angle B, is congruent to angle C. What about if I do this? Now what can you tell me?
The AM is equal to AM.
AM is equal to AM by reflexive.
BAM and NAC are congruent.
BAM and MAC are congruent because they're marked congruent. I agree with you.
Side angle side, those triangles are congruent.
By side angle side, these two parts of the triangle are congruent. I'm okay with that. Would you agree with me that these two triangles are congruent by hypotenuse leg?
Yes.
Why?
No, because there's not a 90 degree.
Isn't it a 90-degree angle here because
It's got by a bisector.
that's a bisector, so it's a perpendicular bisector, which would actually make that congruent to that. That's amazing, isn't it? Look at all that information we just mined. All right, so what if I do this? What if I say that angle is congruent to that angle? And I say this angle is congruent to this angle. Could I say that BM and BK are congruent? How? Could I say that BM and MK are congruent?
Yes.
How?
Definition of the bisector.
How do I know that this is a perpendicular bisector?
Because it goes through the vertex.
Goes through the vertex of what?
Of the isosceles.
How do you know that this is an isosceles triangle?
Because the
Because the two angle,
converse of the
So by the converse of the isosceles triangle theorem, if these two angles are the same, then these two sides are the same. And if those two sides are the same, then by a definition of an isosceles triangle, it's an isosceles triangle. And since it's an isosceles triangle, then this is the angle bisector of the vertex angle. That makes these perpendicular and a bisector. So that kind of sums up all the different things we learned about an isosceles triangle in one nice little package there. Make sure that you do tonight's homework so that you'll be ready to go over the homework tomorrow. I will go through and make sure that the PDF prints out right when I post the answers. So I'm going to be posting 3 things to you on Edmodo by the end of the day. I'm going to be posting you this video. I'm going to be posting you the answers to tonight's homework. And I'm going to be posting you the selected solutions which was really every single problem from the page 246 homework. All righty. That's it.